You cut your hand 3 days ago. It wasn't even deep. A thorn, a sharp rock, a moment of carelessness while gathering firewood. At the time, it barely bled. Now look at it. The skin around the wound has turned an angry red. It's hot to the touch. There's a throbbing that keeps time with your heartbeat, and a faint, sweetish smell that wasn't there yesterday. You're starting to feel it in your whole body now, too. A dull ache behind your eyes, a chill that doesn't match the warm afternoon. There is no clinic down the road, no pharmacy shelf lined with orange bottles, no pill that can reach into your bloodstream and simply erase what's happening inside you. There is only you, your body, and whatever your people have learned to do about wounds like this one, in this place, across more generations than anyone can count. Here's the number that should stop you cold. For almost the entire 200,000-year history of our species, a scratch like this one could kill you. Not eventually, not in some abstract statistical sense. Within days, faster than a broken bone, faster than starvation. An infected cut was one of the most reliable killers a human being could encounter, and it very rarely announced itself as dangerous until it already was. So how did anyone survive long enough to become your ancestor? How did entire populations make it through the plagues, the wounds, the fevers, the childbirths, the everyday punctures of a world with no antibiotics at all? The answer is stranger, older, and more sophisticated than you've probably been told. Let's get into it. Before we talk about how ancient people fought infection, we need to talk about what they were actually fighting, because they couldn't see it, couldn't name it, and yet somehow learned to beat it anyway. Germ theory, the idea that disease is caused by microscopic organisms, wasn't formally established until the work of Louis Pasteur and Robert Koch in the second half of the 1800s. That means for roughly 99.9% of human history, nobody on Earth knew that bacteria existed. Not the healer in a Kalahari camp, not the physician writing on papyrus in ancient Egypt, not the monk tending a hospital garden in medieval Europe. Nobody. And yet infection was everywhere, invisible, patient, waiting in every open wound, every dirty blade, every contaminated wound dressing. A person could survive a lion attack, a fall from a cliff, a battle wound, and still die 2 weeks later from something that had crawled in through the break in their skin while nobody was looking. Here's what made it so dangerous. Without a name for the enemy, ancient people couldn't attack it directly. They couldn't sterilize a tool against something they didn't know was there. What they could do, the only tool they had, was watch. They watched which wounds healed clean and which ones festered. They watched which people got sick after eating certain foods and which didn't. They watched which treatments seemed to help and which ones made things worse. Over thousands of years, across thousands of generations, that pattern of watching became something remarkable. A working, testable, transmissible body of medical knowledge, built entirely without a microscope. This is the part that should genuinely surprise you. A striking amount of it worked. Not because ancient healers understood the mechanism, but because they were running the world's longest uncontrolled experiment. One wound at a time, one generation at a time, and they were paying very close attention to the results. So where did that knowledge actually come from? It turns out the trail goes back further than our own species. At a cave called Shanidar in northern Iraq, archaeologists studying pollen found in a 60,000-year-old burial site uncovered something unexpected: clusters of flowering plants placed near the body. Yarrow, groundsel, ephedra. Every one of them has documented medicinal properties. And the person buried there wasn't a Homo sapiens. It was a Neanderthal. Whether those plants were placed deliberately is still debated by researchers. But here's what isn't debated. We now watch wild chimpanzees, right now in the present day, deliberately treat themselves. When infected with intestinal parasites, chimpanzees seek out a plant called Vernonia amygdalina, which has no nutritional value but does have measurable anti-parasitic properties. They only eat it when they're sick. They've also been observed chewing certain leaves into a paste and pressing it onto open wounds. If our closest living relatives are self-medicating with intention, then the instinct to treat the body with the environment almost certainly predates our species. Which means somewhere in the deep past, long before anyone could write a word down, someone figured out that this plant helps and that plant doesn't, and told someone else. By the time you reach fully modern humans living as hunter-gatherers, that knowledge had become extraordinarily precise. Willow bark, used across ancient Egypt, ancient Greece, and among indigenous peoples of the Americas, contains a compound called salicin. Your body converts it into salicylic acid. That is the direct chemical ancestor of aspirin, discovered independently by completely unconnected cultures thousands of years before anyone understood why it worked. Honey shows up in the Egyptian medical papyri written 3,000 years ago. It shows up in Ayurvedic texts from India. It shows up in ancient Greek medicine. 3 unrelated traditions, no contact with each other, all reaching the same conclusion. And modern lab work has confirmed exactly why. Honey draws water out of bacterial cells through simple osmotic pressure, which kills them. It produces hydrogen peroxide as a natural byproduct. It keeps a wound moist enough to heal without letting bacteria take hold. Hospitals today stock medical-grade honey as a legitimate wound treatment. Ancient healers got there first, by pure observation, with zero knowledge of what a bacterial cell even was. And then there's the detail that should genuinely give you chills. In multiple cultures, on multiple continents, with no contact between them, healers applied mold to wounds. Moldy bread, moldy cheese, moldy grain, pressed directly onto infected skin. It sounds like superstition. It isn't. In 1928, a Scottish scientist named Alexander Fleming noticed that a stray mold contaminating one of his bacterial cultures was killing the bacteria around it. He named the active compound penicillin, and it became the first true antibiotic, saving an estimated hundreds of millions of lives in the century since. Ancient healers were pointing at the same fungus, the same chemistry, thousands of years earlier. They just didn't have a word for what was happening. They only had the evidence in front of them, which was enough. Plants could only take ancient medicine so far. At some point, someone had to cut. On the Indonesian island of Borneo, in a cave, archaeologists found a skeleton with a lower leg that had been surgically amputated. Not torn off in an accident, removed, cleanly, with a sharp tool by someone with enough understanding of anatomy to avoid cutting an artery that would have caused the person to bleed out in minutes. The bone shows clear signs of healing after the surgery. That means the patient lived for years afterward, cared for by a community through a recovery that would have been brutal even by modern standards. This amputation has been dated to at least 31,000 years ago. Then there's trepanation, the practice of drilling or scraping a hole into the human skull. And it may be the single strangest fact in the entire history of medicine. Evidence of it has been found on every inhabited continent, with the oldest examples reaching back more than 7,000 years. And here's the detail that stops most people cold. At many sites, the bone around the hole shows signs of healing. The patients survived. At some locations, researchers estimate survival rates above 50%. For a skull surgery performed with stone tools, with no anesthesia beyond whatever plants were on hand, and absolutely no modern understanding of the brain. None of this happened by accident. Every society we've ever studied, going back as far as the anthropological record allows, has specialists, healers, people who carry detailed knowledge that ordinary members of the group don't have. and who passed that knowledge down deliberately, apprentice to apprentice across generations. This was medical education. It wasn't written down for most of human history, but it was systematic, structured, and taken extremely seriously. Because a break in that chain of knowledge meant people would start dying from things that used to be survivable. And it wasn't only about plants and blades. Ancient people also understood something that modern medicine took an embarrassingly long time to formalize: keep it clean. Wounds were flushed with wine, with vinegar, sometimes with fresh urine, which is sterile and was genuinely used in emergency situations, even in modern field medicine. Wine contains alcohol. Vinegar is acidic. Both are hostile to bacteria. Nobody treating a wound with diluted wine in ancient Greece knew what a bacterial cell wall was. But they could see, over and over, that wounds cleaned this way did better than wounds left alone. Centuries later, in the hospitals of the Islamic Golden Age, physicians formalized something that reads almost like a modern infection control manual: separate wards for different illnesses to stop the sick from infecting each other, mandatory hand washing for staff, clean linens changed regularly, ventilation designed to keep air moving through patient rooms. These weren't superstitions. They were rules built from centuries of watching what happened when hospitals didn't follow them. But knowing how to treat a wound was only half the war. The other half was knowing how to keep an entire community from being wiped out by something you couldn't even see coming. Here's the cruelest part of pre-antibiotic life. It wasn't only about individual wounds, it was about outbreaks. And outbreaks moved faster than any healer's knowledge could keep up with. When the Black Death swept through Europe in the 1300s, killing an estimated 1/3 to 1/2 of the entire population, nobody understood bacteria. Nobody understood fleas as vectors. Nobody understood the disease at all. What they did understand, eventually, through devastating trial and error, was distance. The city of Venice began requiring ships arriving from plague-affected regions to sit offshore and wait before anyone could disembark. The waiting period was 40 days. In Italian, 40 is quaranta. That's where we get the word quarantine. Nobody in Venice knew what a pathogen was. They knew that sickness seemed to travel with people, and that waiting seemed to break the chain. That single observation, applied without any understanding of the mechanism behind it, is still one of the most powerful tools in infectious disease control today. And this is where the story gets genuinely tragic. Because for every insight, like quarantine, there were mistakes that cost enormous numbers of lives. Bloodletting, based on a flawed theory of bodily humors, persisted for over 2,000 years, despite weakening already sick patients. Wounds were sometimes packed with substances that introduced more contamination than they cured. Fear and superstition occasionally overrode observation entirely, and when that happened, people who might have survived didn't. The difference between the practices that worked and the ones that didn't almost always came down to one thing: how closely anyone was actually watching the outcome, and how honestly that outcome got passed on to the next generation. The healers who survived, whose knowledge survived with them, were the ones who paid brutal, unflinching attention to what actually happened to their patients, not what they wished would happen. So, would you have survived back then with that infected cut on your hand? Maybe. It would have depended less on luck than you'd think, and more on which community you were born into, and how much hard-earned knowledge that community had managed to keep alive. Whether someone nearby knew that honey on an open wound does something real. Whether someone had learned, the hard way, which bark to boil for a fever. Whether your people understood, even without a word for infection, that distance from the sick sometimes saves the healthy. None of that knowledge came from books. Because for most of human history, there were no books. It came from watching, from remembering, from an unbroken chain of people who paid attention when someone lived and paid even closer attention when someone died, and who refused to let what they learned disappear with them. When Alexander Fleming looked at that stray mold in 1928 and changed the future of medicine forever, he wasn't starting from nothing. He was putting a name and a mechanism to something ancient healers had already been reaching for, blindly but correctly, for thousands of years. Modern antibiotics didn't erase ancient medicine. They explained it. And there's a strange, humbling twist to end on. Today, bacteria are evolving resistance to the very antibiotics that were supposed to have solved this problem for good. In a way, we're being pulled back toward a question our ancestors never stopped asking. What do you do when the invisible enemy adapts faster than your defenses? They didn't have microscopes. They didn't have germ theory. What they had was patience, memory, and the refusal to let hard-won knowledge die with the person who learned it. That refusal, passed down through more generations than we can count, is the reason any of us are here to ask the question at all. If you enjoyed uncovering the real history behind one of humanity's quietest survival battles, subscribe to Ancient Actually. Every week, we separate myth from evidence and reveal the remarkable ways ancient people survived a world that was far harsher than most of us can imagine. Because history isn't just about what happened, it's about discovering why it happened and what it can still teach us today.